Hello, my name is Abby Hattinger, and today I'm going to be talking to you about the Pythagorean theorem for my Math and Innovations project for Math 263. So the Pythagorean theorem is a fundamental geometry rule stating that any right-angled triangle, and only right-angled triangles, that the area of the square on the longest side, which is also called the hypotenuse, is equal to the sum of the areas of the squares on the other two sides. So my two legs here, each piece being squared. So the formula looks like a squared plus b squared is equal to c squared. A and b are the legs and c is the hypotenuse. The Pythagorean theorem has lots of real-world applications, such as in architecture and engineering. Builders use the 3, 4, and 5 rule, which is a Pythagorean triple, to ensure that walls are perfectly perpendicular. It's also used in navigation and travel to find the shortest path, calculating the direct diagonal distance between 2 points. And it is also used in ladder safety because no one wants to fall off a ladder, so this is very, very helpful. And you can determine how high a ladder will reach when it's placed at a safe distance from a wall. So that way when you go up the ladder, you don't go, oh man, I should have gotten a tall ladder, I gotta climb all the way back down. That would not be very fun. So for today's problem, I'm going to be solving this word problem. A 13-foot ladder is placed against a wall. The base of the ladder is 5 feet away from the wall. So my A, one of my legs, is equal to 5 because it is placed 5 feet away from the wall, so it's the ground. We don't know what the wall height is, but we do know the hypotenuse, which is c, 13, so c is my ladder. So I plug in the 5 and I square it, and then we don't know what b is, but b is squared, and that's equal to 13 squared. 5 squared is 25 plus b squared, which is equal to 13 squared, which is 169. B squared is equal to 169 minus 25, because we took the 25 and subtracted it on both sides in order for b to be by itself. So we subtract these two, and then we get b squared is equal to 144. Then you want to take the square of both sides to get b by itself. That gives you b is equal to 12 feet. So my wall, the height that my ladder will reach on the wall is 12, according to the Pythagorean theorem, which is very helpful to know. So the Pythagorean theorem is also the foundation for trigonometry. It is the starting point for calculating angles, distance, in more complex shapes, which is really awesome. And it's also used in modern technology. It's used in today's GPS tracking. It's used in cell phone location services. And it's also used in creating 3D environments, such as in video games, which is very, very cool. So this is my project for Math 263 on the Pythagorean theorem. Again, the formula is a squared plus b squared is equal to c squared. A and b being the legs, c being the hypotenuse. And here was my problem that we did. And thank you for watching. Hey.
Hello.
What are you working on?
Oh, nothing. I'm just doing my engineering homework.
Can I see?
Sure.
What is this?
So actually, one of the properties we're using right now in my engineering class is Ohm's law.
Ohm's law?
I know what that is. I'm an engineering student too.
So, do you want to explain it to me?
Sure, we can. Let's go.
So, what even is Ohm's law?
So actually, Ohm's law talks a little bit about the electrical flow within a certain object, and so it could be simply put just as a light bulb, which you saw me working on there over there.
Is there a formula for it?
Oh yeah, of course. And there's 3 properties, which are voltage, current, and resistance.
So actually, I have a problem for you if you want to read it aloud for us to help you better understand the property.
Sure.
Here you go.
Thank you. So, this word problem says, an electrician is installing a custom light fixture in a workshop. The fixture is connected to an 120 volt power supply, and the electrician wants the circuit to allow 0.75 amps of current to flow through the light bulb so it operates safely.
So in this problem, the resistance is unknown, so that's what we're going to be solving for. Okay, first step 1 is going to be V equals I times R. V is for voltage, I is for current, and R is for resistance. I is in amps, and R is in ohms.
So for the second step of the problem, what you would do is you would rearrange this original formula that Angelina gave us earlier. That would be R equals V over I, which is simply put, the resistance equals the voltage over the currents. And for this problem, the voltage is 120 volts, as I stated before when she was reading out the problem. And I, which is the current, would be at 0.75, right? And so for the problem, you use the voltage over the currents, and so you would put 120 over 0.75. And that will simplify into 160 ohms. And now for the second part of this problem, you would introduce the power rule, which is simply put the power times the voltage and the current, what equals the voltage and the current. And it's P equals V times I. And so in order to find the power for this problem, you take the same trace that we have right here and you multiply. So it would be 120 volts times 0.75. This will simplify into 90 watts. All right, now we just solved for that problem. How do you?
This problem demonstrates how Ohm's law is used in real-world electrical designs.
Once the current is known, calculating the power shows how much electrical energy the light fixture will consume. And this problem right here that I just worked out, it's erased now, but it was 90 watts. That would be your final answer, and that shows how much electrical power the problem has. How do you feel about it now?
I think I'm starting to understand it. Thank you for explaining it to me.
Yeah, anytime. They're supposed to sound interesting.
I'm so glad they taught me how to work out Ohm's law.
For our Math and Innovations project, we decided to study the printing press that was made by Johannes Gutenberg. And it's a perfect example for the Math and Innovations project because it shows like the increase in output over time of the pages. So the calculus is the study of time, so study of change over time. So if we study the printing press, that could show how many pages are being made over time, and especially with new innovations being made and it increasing. So if we decided to set it up, we could do an example of P of T equals 120 T. So the P of T is the pages over time, and then if we said T is hours, P of T equals number of pages. This would mean that over each hour, so 1 hour equals 120 pages. And then we could take that up a notch in a second.
As time went on, improvements were made to the printing press, and it can be shown by the equation P of T equals 100T plus 10T to the power of 2. Since the equation is not linear anymore, it is quadratic, and as a result, we have to use calculus to figure it out. So we would take the derivative. P prime of T would equal 100 plus 20T. And as a result, to figure out how many the printing press makes after a certain amount of time, you plug in an integer for T. So for example, we'll do 2, 4, and 6. So you do P prime of 2, you just plug that in to the P prime of T equation, and P prime of 2 would give you 100 plus 40, which equals 140. So that would mean, for example, 140 pages would be made per hour. And if we took it up a notch and did P prime of 8, we would do the same thing but plug in 8 for T. This would give you 260 pages per hour.
And if we want to take this up an even further notch and like represent how the rate was changing over time, we could represent that by P double prime of T. So for example, if we took that original equation that Kamari did of P of T equals 100T plus 10T squared, that would first take the first derivative. So that would be 100 plus 20T. And then if we want to take the double derivative, that would just be 20. So since T is our hours, if we wanted to find how much it would be increasing for hour intervals, so T of 1, T of 2, and T of 3. So for 1 hour, it would just be 20. And since there is no variable, you can't plug anything in, but we can recognize that it is increasing hourly, so P of 2 would be 40, and then P of 3 would be 60.